Now we're going to look at exploring how to multiply with radicals in that. So we're going to start out by multiplying a radical across a summation, or one term times two terms. So root 7, well, it looks like a standard distribution property, and you're right. I'll take the square root of 7, distribute it to the x to the first term, and take it and distribute it to the second term. So when doing that, I'll have root 7 times x plus, let's make that a root 7 times an x plus root 7 times root 2. So you see, I distributed the negative 7 across both terms. Now I multiply root 7 times an x. That is an x root 7. I can't combine those terms in any way. It just becomes x root 7 and plus root 14. And from there, I check to see if there's any perfect squares in root 14 that are factors. There are not. And so my result is completed. I also saw earlier, if I did factor it, I guess I did see that those two root 7s there, but can't do anything with it. It really is a root 14, and there's my final result. Another example where I'm multiplying a one term times a two term. Again, when we do that, we're going to involve our distribution property. So we're going to distribute the cube root of x to the first term and then distribute it to that second term as well. So cube root of x times this first term, the cube root of 6, minus a cube root of x times that last term. From there, let's see if we combine. We can multiply radicals if they have the same index here. So the cube root of x times the cube root of 6 becomes the cube root of x6, or 6x, since I like writing the coefficients first, minus the cube root of x times x squared becomes an x cubed. From there, are there any perfect cubes I can factor out? The cube root of 6x, there are none. So that remains the cube root of 6x minus the cube root of x cubed is an x. And now that problem is sufficiently simplified and solved. Here we're going to multiply two terms times two terms. And I hope that evokes some memories of how we learned to do that earlier with a concept called FOIL, where we multiplied first terms times first, outers times outers, inners times inners, and last times last. And basically what that is saying is that we want to make sure every term in here gets distributed. So the 2/3, just like we've done before, 2 root 3, just like we've done before, it gets distributed to both of those terms. And this other term, we have to make sure it gets distributed to both of those terms. So we have my first times my first, my outers times my outers, my inners, and my last. So let's work through that, and we'll try to go step by step and nice and slow. So first times first, I have a 5 root 2 times a 4 root 2. Then my next set of terms are my outers. So then I have a 5 root 2 times a negative 3 root 3. So we're going to add a 5 root 2 times a negative 3 root 3. All right, halfway done. Shake it out. All right, then I'm going to do my inner terms. So let's add those to it. So this becomes a 2 root 3 times a 4 root 2. And the last set of combinations I need to correspond with are my last terms. My 2 root 3 times a negative 3 root 3. And there we have everything. I hope you can see, and I'll kind of put that out here, is here's my firsts, here's my outer terms, here's my inner terms, and there's my last terms. It's just a way to help us remember and to keep track of all the multiplications that we have to do. Now we can simply simplify. 5 root 2 times 4 root 2. We're not adding this time, so this becomes 20 times 2 times 2 inside the roots, because we multiply inside the roots, and we'll work that out on the next one, but I just wanted to show you that one. 5 times that gives me a negative 15, and in the inside I have a 2 times a 3, plus 2 times 4 is a 6. Multiply the insides of the roots. I just went and multiplied that time. It's still a 2 times a 3. I just multiplied it as a 6. I guess I was skipping or jumping ahead of myself. And then the last one, 2 times a negative 3 is a negative 6. And on the inside, I have a 3 times a 3. Let's clean all those up step by step. So I have 20 times root 4 minus 15 root 6 plus 6 root 6 minus 6 root 9. 20 root 4, that's 20 times a 2, minus 15 root 6, plus 6 root 6, minus 6 times 3. 20 times 2 is a 40, minus 15 root 6s plus 6 root 6s. I'll combine them now. I could have done it earlier, but I'll do it now. What is that, folks? Is that negative 9? Negative 9 root 6. And my last term, minus an 18. I can combine my 40 and my 18. That will provide a 22. 22 minus 9 root 6. Now the problem wasn't overall complicated. We just had to make sure that we started off well and just did it step by step by step, because each step was a nice small step. But combining all of them might make the problem look overwhelming. So if that's the case, just remember, step by step, you're going to be able to do it. Solve the first problem, then you can go on and solve the next problem. And you solve enough, you're eventually going to be able to find your way home. All right, how many of you guys saw that? Looking at this after I got done, I was looking through it and going, wait a minute, something still didn't feel right, so I had to just double check everything. How many of you guys were bothered by this 6 right here? Well, I wasn't originally, but I'm sure you were as you're walking through that. Really, what should that be? 2 times 4 is really an 8, isn't it? So this should be an 8. Nope, not that one. This one should be an 8. This one should be an 8. And if that's the case, then 15, negative 15 plus an 8, well, this makes this one a 7. So my final result really should have been 22 minus 7 root 6. Boy, isn't it easy where a mistake can creep in and just tracks it all the way through. But the good thing is, if you go step by step, you'll be able to discover those mistakes a little bit easier and see where they're at. If I just get from this step down to here, oh, I may not have found it. And I may not have known anything. So anyway, apologize for the mistake, but that's how I learn.